we begin to talk about multiplying with decimals, there are some old ideas that we need to connect to, some things that should be very solid for you. But then we need to also begin looking at the multiplication and what it means in a new way. So first of all, connecting it to the old. If we are going to solve 3/10 times 7/10, that looks an awful lot like 3 times 7. So that's where we're going to begin. First of all, we have 3 groups of 7 items. Well, 3 groups of 7 items each means there are 21 items. So that's our connection to the old. But now comes our new. If we have not 3 groups of 7 items, but if we have to take 3/10, a small piece, of 7/10, an even smaller piece, we should expect to end up with less, not more. Today we're going to work with some models to begin to see what that might look like. So they've tried to show you this already, but it's kind of confusing unless you really investigate. So first of all, we've worked with decimals and these models of blocks before, where there were 10 rows this way and 10 columns this way, so that we had 100 pieces. So each little square was hundredths. Each row or column was tenths because there are only 10 rows and 10 columns. So if we look at 7/10, where do we get the 7/10? Well, there is 1 column out of 10. There is the second column out of 10, and I'll even zoom in closer for you. The third out of the 10 columns. Here's 4 out of 10, 5 out of 10, 6 out of 10, and 7 out of 8, 9, 10 columns. So the green is showing 7/10. Now we talked about multiplying being of. So of these 7/10, I only want to take 3/10. Actually, I think I'll use my regular pencil here to help show you that. So the 3/10, there's 1 out of the 10 rows, 2 out of the 10 rows, and 3 out of the 10 rows. But we don't want to take 3/10 of the whole thing. We only want 3/10 of these 7/10. So to count the little boxes, I want to know how many of these hundredth pieces there are if I take 3/10 of only the 7/10. Well, you can see there are 3 groups this way. There are 7 groups this way. And we already know 3 times 7 is 21, right? That's connecting it into the old. But then we have to look at what size are those pieces. So yes, we have 3/10 times 7/10. There are 21 pieces, but those pieces, there are 100 pieces that are this size. So we need the decimal right here. Now there is a bit of a shortcut. When you are doing regular multiplication and there are decimals in the problem, you check to see how many decimal places you have entirely in the multiplication part. Here is one digit to the right of a decimal. Here is a second digit to the right of the decimal. Which means to get the decimal placed, if it starts out as 21 whole things, we need to move it one place, two places. This I call doinking the decimal. Why would we doink it starting from a whole number and making it smaller? Because we are taking one little part of another part. So when you take part of a part, your answer gets smaller. So yes, our digits 3 times 7 give us the 21, but we move the decimal 2 places because that is what makes our pieces show that we are taking 3/10 of 7/10. What does that look like in a different problem, one that you might not be as familiar with? Well, here we have 4/10 times 2 4/10. This is a multiplication that you wouldn't know in your head. So how can I connect this problem, 4/10 times 2 4/10, to what I know about multiplication? Well, if we think back to what I called doinking the decimal, we can do this in regular multiplication. When we added decimals, we lined up the decimals. When we are multiplying, we do not. When we are multiplying, no matter how large or small the numbers are, you line the digits up when you have to do some work with the most digits on top and the least digits on bottom. Does not matter where the decimal is. In this case, it happens to be lined up, but that does not mean we're bringing it straight into the answer. We are totally ignoring the decimal until we're all done. So we multiply this exactly as it is, as if it is 24 times 4. So 4 times 4 is 6, carry the 1. 4 times 2 is 8, plus 1 is 9. Now we're all done with our regular multiplication. Then we have to look and see, where is the decimal? How many digits in the decimal places? We only have one digit here. Down here, where's the decimal? How many digits to the right of the decimal? There's the second one. So then we look at this as if it's 96, but we need to move our decimal from the whole amount to make this smaller because we are taking part of a part. So this shows that I moved the decimal once, twice, and it ended up right here. So my final answer is 96 hundredths. What does that look like on the model? Well, you can see that there are hundredths, but they're showing you one entire amount, two entire amounts, and three entire amounts. So right now there are 300 of these little tiny squares. But we need to look at 4/10 of 2 4/10. So I'll start out and show you the 2 4/10. 2 4/10 would be all of this That's 10/10, so there is one whole thing. Should be kind of obvious that that will be the second one. I'm not doing very good at staying in the lines. 6, 7, 8, 9. There's my 10/10. So total I have 20/10. Now I only need 4 more tenths. 1, 2, 3, 4. So there's my 4/10. 2 whole things, 4/10. Of those 2 4/10, however, I need to take 4/10 of that amount. So the 4/10, there's 1/10, there's 2/10, there's 3/10, there's 4/10. But I don't want this extra part. I only want 4/10 of those 2 and 4/10. So here I have 40 out of 100. Here are another 40 out of 100. And here I have 4 times 4. 4/10 this way, 4/10 this way. That would be 16 out of 100. 40 and 40 is 80. 80 plus 16 is 96 out of 100, which matches exactly 96 hundredths. We are going to do some more models. Your homework is going to be just to do the regular multiplication. I want to show you the models. So we're going to take 4/10 of 8/10. So there's my 1/10, 2/10, 3 out of 10, 4 out of 10, 5 out of 10, 6 out of 10, 7 out of 10, 8 out of 10. So the green is my 8/10. Of those 8/10, I only want 4. 2, 3, 4. So I'm interested in just these 4/10 of the 8/10. So I'm only interested in this amount right here. So 4/10 times 8/10, you should know there should be some sort of 32. But what are the size of these pieces? Another way to think about it, if you have 4/10 times 8/10 equals 32, how many times are you going to have to doink the decimal in order to end up with 2 digits behind the decimal? The decimal always starts as if it was a whole number, and when you're moving it to multiply, you are going to make it smaller because you are taking a small amount of a small amount. For your homework, you will need to write down all of these multiplications just like this, but you will also have to show the decimal moving, and then your final answer will get rewritten up in the blank. What do I mean by showing the decimal moving? All right, I'll show you the whole thing on this one. We must move the decimal not one place. We must move the decimal 2 places because there are 2 digits to the right of the decimal total in the problem. So we need to make these places smaller by 2 decimal places, which means the final answer is 32 hundredths. You don't need to do the modeling for each one, but you must show me each problem on this page written out as multiplication with the decimal moving. I am going to show you the modeling for a few more here. I will show you the modeling for 5/10 of 6/10, which means I need to start with 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. tenths. Of those 6/10, I want to take 5/10. So remember, here were the 6/10, but I don't want all of them. I just want a piece of them. 1/10, 2/10, 3/10, 4/10, 5/10. But I don't want 5ths of the entire box. I only want 5/10 of the 6/10 that I took in the first place. So this amount right here shows 5/10 of 6/10. The multiplication gets written out. You need to show the answer, as we did. You need to show that you've counted the decimals. You need to show that you've doinked the decimals. And then you need to write your final answer in the blank. You do not need to do the modeling like this. You must write the multiplication, count the decimals, doink to show that you're taking a part of a part, and write your final answer up there. Number 8, 2/10 times 9/10, or 2/10 of 9/10. I'm not going to show you that one. I'm not going to show you 4/10 of 6/10. I do, however, want to show you 3/10 of 1 8/10 for two reasons. One reason is you'll set this up a little bit differently. You'll set it up just like I set up 2 4/10 times 4/10. The number with the most digits needs to go on top of the multiplication. You do not line up the decimals, but before I show you that, I want to show you, all right, 1 8/10. Well, 1 means I can color in the whole thing right away. That's one entire amount. And then I need 8/10. 1, 2, 3, 4, 5, 6, 7, 8. You're probably wondering why they give this one. I'll show you that in a moment. Right now, I'll take 3/10 of that. Now, 3/10 of 1 8/10, there's 1/10 of what they gave me. There's 2/10. There's 3/10. But now, remember, if I want 3/10 of 1 8/10, I don't want these extra parts. I just want 3/10 of the 1 8/10. So this one, it almost helps if I use another color here. This is the amount that I want. The reason they're showing you, they're giving you this other box for the modeling, it's hard to really tell how much there is having it spread across 2 whole squares. So you know there would be 3/10 out of this whole square. That would be the same as 30/100ths, right? So we would just write that as 30/100ths. Here, though, there are 3/10 of these other 8/10. 3 times 8 is 24, so we knew that would be 24/100ths in this part. 30/100ths in this part, 24/100ths in this part. You would have to put that together in order to see it in the model. So they're wanting you then to do your 30/100ths down here. So all the way across the one whole item, just like it was here. And then pile the 24/100ths on top. And figure out how much that is all together in one spot. So that's why they gave this separate box. Do you need to worry about the models here? No. What you need to do, however, is figure out the best way to write this so that you can multiply it the way we've practiced. 2-digit multiplication, we put the more digits on top. 1 8/10 has 2 digits. 3/10 just has 1 digit. It doesn't matter where the decimals are when you multiply. Does it matter where the decimals are when you add? Absolutely. This happens to be set up so that you could add it perfectly, but we're not interested in adding. The sign says to multiply. So you need to multiply, then you need to show that you've counted the digits to the right-hand side of the decimal places, so that you're keeping track of how small the pieces are getting. Then, once you have the answer, you need to doink the decimal. Have the decimal end up where it belongs so that you show that you end up with small pieces. Your final answer goes up here in the box. Your assignment today is to do all of page 399. No models. So you don't need to color anything else. No models, but you must multiply, count decimals, doink decimals, and write your final answer. Multiply, show the work. This should be pretty easy to show the work, but it's very important to show what you're doing with the decimals to get the final answer. That goes right up at number 8. So your work for number 8 will go here. Your work for number 9, write it there as if you had to do a lot of work, even though you should know 4 times 6, the multiplication, but show me what you do with the decimals in this box. Your final answer goes up on the line. Number 7, show the multiplication. What do you do with the decimals? Final answer goes up on the line. You do not need to color any of these models. You do not even need to copy the color that I did. You must, however, show your multiplication, what you do with the decimals. The final answer goes up on the blue blank, but you need to show me what you're doing with the decimals to get the final answer. Remember, when you multiply with decimals, you are taking a small part of the other amount, so you will end up with smaller pieces. And this is our first introduction to that, so be careful. Make sure that you send this page 399 to me. That is your homework assignment.